to I don't think it's going to be our last unit, because I think we should be able to cover one more unit, which is a good thing, after the break. That last unit will be after the break. So we're going to work on trigonometry right now. Trigonometry is the study of triangles, right? So we deal with triangles, we deal about like finding the measurements for triangles, either angles, sides. We work with right angle triangles and we work with oblique triangles, okay? So the right angle triangles are triangles that have the 90-degree, and the oblique triangles, they're the triangles that don't have the 90-degree, okay? So oblique triangles are the one that don't have the 90-degree. Now, first we're going to look at some vocabulary here, and then of trigonometry, and then some rules, and then we will do trigonometric ratio with right angle triangles today. So the important vocabulary that we're going to talk about is the angle of depression and angle of elevation. Okay, I talked about that I think before, no? With you or no? Probably with you in the class. So if I'm looking and I'm looking up at the clock, right? So yes, you don't see the lines, but there is a line that's coming out of my eye of sight to the clock, right? So pretend this is your clock right here. So pretend this is the clock right here. You're standing right here, right? There is a line between you and the clock, between the line of vision and the clock. So I say that the angle of elevation to the clock is 20 degrees, okay? How do I measure that 20 degrees? That 20 degrees is measured with the horizontal, okay? So it's a line, it's an invisible line that's coming out of your eye of sight that is horizontal, okay? And then there is a line that's coming out of your eye of sight to the clock. So you see that these two, they're going to form an angle, okay? So this is the horizontal that's coming out of your eyesight. This is the line that's coming out of your eyesight to the clock, right? And that angle here is called the angle of elevation. Okay? Do you understand that? Now, if I'm standing here and I'm looking at the ground as well, right? I'm looking at the bed, for example, right? So there is also a horizontal line coming out of my eye of sight, and there is the line that's going from my eye of sight to the object, okay? And then there is an angle that's forming the two, between the two. So what do we call that? Depression. Angle of depression, okay? It's called angle of depression. So again, it's from a horizontal line down to the object, okay? So usually the way I draw it, so this is your eye of sight. You're looking at the clock here, for example, right? So this is going to be your angle of elevation. If this is your eye of sight, okay? And then if you're looking at the bag on the bottom, right? This is the angle of depression. Okay? So it's always measured from the horizontal line that's coming out of your eye of sight. Are we okay with that? So an angle of depression is an angle that falls from the horizontal, also known as the angle of declination. And an angle of elevation rises from the horizontal, also known as the angle of inclination. Now, in math, we use a lot of Greek letters. There's a lot of Greek mathematicians, so that's why we use a lot of the Greek letters. And one of the ladder theta, which looks like this. So it looks like an O, okay? It's called the letter theta, and that letter theta is usually used to represent angles that we're looking for. Now, that doesn't mean we can't call angles angle A, angle B, angle C, whatever, right? It could be called anything, but you'll see this often, that symbol often, and that's the letter theta. What do we call the triangle that has a 90-degree angle? Right angle triangle. Any triangle that is not a right angle triangle is an oblique triangle. So the name for the non-right angle triangle is an oblique triangle. Now, under the oblique triangle, there's two types of triangles. Okay? You either have the acute triangles, where all your angles are acute angles. Acute means what? What does acute mean? You know? Less than 90. So an acute angle is less than 90 degrees. Okay. And then an angle that has one obtuse angle, it's called an obtuse triangle. And do you guys know what an obtuse angle is? It's between 90 and 180, yeah? So it's an angle between 90 and 180. We call that obtuse. Okay? And then a right angle is a 90-degree angle. Are we good with that? So make sure you know these terminologies. Acute is less than 90. Obtuse is between 90 and 180. And then 90 degrees is your right angle. Now, the sum of the angles in a triangle is 180, right? So no matter how the triangle look like, right? When I add all the three interior angles of the triangle, they're gonna all add up to 180 degrees. So now we're gonna focus on the right triangle, okay? In the right triangle, I have the 90-degree angle that's indicated by that square kind of notation. So this is how I know it's right angle triangle. Okay? Now, the other angle, which is in this case angle theta, right? So this is my angle of focus, right? I always have, in the right angle triangle, I always have a 90-degree and an angle of focus. The angle of focus is usually the angle that you're looking for, or the angle that you want to, that you know, okay? Either the angle that you are looking for, or the angle that you know. So we call that the angle of focus. It's important to know where the angle of focus is, because the name of the adjacent and the opposite depends on where is my angle of focus. Okay? So I'll show you another example. But first, the hypotenuse change its location. Always across from the 90. Now, so it's the longest side. And is across from the right triangle. Now, according to the angle of focus, I have two other sides, the opposite side and the adjacent side. Okay? So if this is my angle of focus right here, then my opposite side is this side, right? Because that's opposite from my angle of focus. And then my third side, the other side that's not nominated yet, it's called the adjacent. Okay? So the side labeled is across from the angle of focus in the right triangle. So the side labeled opposite is across from the angle of focus in the right triangle. And the side labeled adjacent is attached to the angle of focus in the right triangle. And the angle of focus is the angle given or the angle to be found in the right triangle. So we call that the angle of focus. You also sometimes hear me say angle of interest. It's the same thing. Angle of focus or angle of interest. Let's look at this triangle here that I've drawn before. And which angle is my right angle? Which angle is my 90 degree? B, right? So this is my 90 degree. And my angle of focus is? It's angle A, right? Because that's the one I called theta. That's my angle of focus. Where's my hypotenuse? AC, because that's the one that's across from the 90 degree, right? So this is called the hypotenuse. Where is my opposite? BC, right? Because that's the one across from the angle of focus. So that's called the opposite. Right? Where would be my adjacent? AG, right? Because that's the only one that I still have to do. Okay? So you have to know where your right angle is, and you have to know where your angle of focus is. No matter how the right angle triangle look like and which direction it's facing. Are we okay with that? Naming the triangle is half the battle. Properly naming the triangle. So, to properly label the triangle, you always use capital letters for the angles and small letters for the sides. Okay? So if I have, for example, this triangle here, and that's triangle ABC, okay? You see how the angles are labeled with capital letters, all right? Now, if you look at the sides, we're gonna label the side that's across from angle A, we're gonna label it with small a. Across from angle B, it's gonna be named side B. Across from angle C, it's going to be labeled side C. Okay? So you always do that. With oblique triangles or with right angle triangles, you always name the angle and the corresponding side across from each other. triangle that I just drew, which one do you think is the largest angle? Like from the way it looks. Angle A, right? And which one do you think is the largest side? BC, which is side A, right? You always have that scenario, okay? The biggest angle is going to have the biggest opposite side. And the smallest angle is going to have the smallest opposite side. Does that make sense? So if you look at side C, or angle C, right? Side C is going to be the smallest because angle C is the smallest. Now, when a question says to solve a triangle, if I ask you in the question, solve the triangle, I am looking for every single measurement inside the triangle. I'm looking for all the sides, and I'm looking for all the angle measurements. Okay? It means find every missing angle and every missing side. Are we okay with that? Any questions? All right. Make sure that your calculators are in degree mode. So either the calculator says nothing on the top, or it says D, or it says DEG. D, DEG, or nothing. Okay? Usually either at the top or the bottom. You should see that letter. Okay? D or DEG. Yep. Usually the calculator, they come as D. All right. Yeah. Also, you should be able to locate on your calculator the buttons that says sine, cosine, and tan. So SIN, COS, and TAN. Right? You see them on your calculator. And on top of these, usually, as the second function, you see the sine inverse, cos inverse, and tan inverse. So the one that has a -1 on top. Okay? So you know how the opposite operation of addition is? What's the opposite operation of addition? Subtraction. What's the opposite of addition of multiplication? Division. What's the opposite operation of square? Square root. Right? What's the opposite operation of sine? Is sine inverse. Okay? So it's the same idea. If you think about like addition, subtraction, multiplication, division, whatever, the sine inverse is the opposite operation of sine. Cos inverse is the opposite operation of cos. Tan inverse is the opposite operation of tan. Okay? Now, unless the question asks you otherwise, you're going to leave your side length to the nearest one decimal. So when you're solving for side length, you're going to leave it to one decimal. And then your angle should always be to a whole number. You should not leave your angle as like 34.2. It's 34 degrees. Okay? Angle should be to the nearest degree. And then if you're finding your trig ratio, so if I ask you to find sine 40 degrees, right? When you do the answer for this, leave your answer to 4 decimal places. So can you guys do me a favor on the calculator, do sine 40? So you have a number that's 0 point something, right? What's that number? 0.642. So 8, right? Because this is, we call this trig ratios, okay? We call this trig ratios, and trig ratios, you should leave them to 4 decimal place, okay? So whenever you do sine of an angle, or cosine of an angle, or tan of an angle, you should leave your answer to 4 decimal place, okay? Side length 1 decimal, angle to the nearest degree, trig ratios to the nearest 4 decimals.
Sorry, what's trig ratio?
So trig ratios is whenever you do sine of an angle. It's called, they're called trigonometric ratio, okay? Sine, cosine, and tan, that's their name. That's their all together. We call them the trigonometric ratio, okay? And then we're gonna talk about what they are. But then if I do sine of 70 degrees, right, that's called the trig ratio. Cosine of 45 degrees, that's a trig ratio, okay? So this operation, they're called trigonometric ratio, okay? Tan of whatever, right? Tan of 22 degrees, right? These are called trigonometric. Okay. Are we okay with this? Now, remember that labeling a triangle is important. You need to know where your angle of focus is. You need to know where your right angle is, so you can name your opposite, adjacent, and hypotenuse. Now, eyes on me for a second. The primary trigonometric ratio. Okay? The primary trigonometric ratio, they represent sine, cosine, and tan. The reason why we call them primary, because these are your primary ones, and we have the secondary ones, which are the reverse, the inverse of them, which we don't talk about this in this course, okay? But they're called cosecant, secant, and cotan. We don't cover them in this course, okay? The primary one that we cover in this course, they're sine, cosine, and tan, okay? We call them the primary trigonometric ratios, okay? The primary trigonometric ratios, sine, cosine, and tan, they're used to, or we call them SOHCAHTOA. We'll talk about what SOHCAHTOA stands for. They're used only with right angle triangles, okay? The SOHCAHTOA, or the primary trigonometric ratio, are used only for right angle triangles. You cannot use them for oblique triangles. There's other laws that we use to solve oblique triangles. Let's figure out what happens in the right angle triangle, and let's try to compare some triangles. So I have triangle ABC, and I have triangle XYZ, okay? And let's look at the measurements, and then let's name the triangles. First of all, What do I know about triangle ABC? What kind of triangle is this? Right angle, right? I know this is 90, right? What's the angle A measurement is?
180.
What's the A measurement?
Oh, it's 37.
37. Can I find angle B?
Yeah.
What's angle B?
53.
How did you do that?
90 plus 37.
Yeah.
And the 100 minus the,
So you did 180
yes.
minus 90 minus 37. And you got 53, correct? Okay. So to find measurement of angle B, you subtract 180 minus the other two angles. Now, according to angle A, because that's my angle of interest, that's the angle that they gave me. According to angle of focus, A, where is my opposite, where is the adjacent, where is the hypotenuse?
The opposite is BC.
The opposite is BC, do we agree with that? Opposite to 37 is BC. Okay, what else?
The adjacent is AC.
The adjacent is AC,
And the last one is height.
so the adjacent is right here. And then the hypotenuse is B or AB. Why is the hypotenuse AB? Why is AB the hypotenuse?
Because the opposite of,
Because it's the 90 degree. It's across from the 90 degree. It's only called the hypotenuse if it's across from the 90 degrees. How about in angle XYZ? So my angle of focus again is at 37. Right? Where is the opposite? Where is the adjacent? Where is the hypotenuse? Take a minute to name the triangle. So to name the sides. Opposite, adjacent, and hypotenuse. First of all, practice the language. Sometimes they have asked, they ask you to go through it, so maybe you do some division first and then go back. I'll say that English.
This one has a coefficient in front of the x, so I have to do the factor of this as well, right?
You have to, yeah, so you have to divide the factors of this by the factors of this. No, just me, give me that.
Yeah,
Like
sure.
that.
Sure.
Yeah,
This one's always
touching me. Yeah,
is a height.
it's
The
always
two
the
lines.
hypotenuse and angle, yeah.
Yeah.
All right, so where's the hypotenuse? Huh?
Line x one.
XY, yeah. And where's the opposite?
this is YZ.
And then the adjacent is X. Okay, now, they want us to do the following. They want us to use the triangle ABC, and they want us to divide the opposite over the hypotenuse. Okay? So in triangle ABC, what's the measurement of my opposite?
Is 3.
What's the measurement of the opposite? It's 3. Divided by, what's the measurement of hypotenuse?
It's 5.
5. So 3 over 5. Can you give me that answer to the near to 4 decimal place?
0.6.
6 what? Just 6?
0.6, yeah.
Okay. Now, in triangle XYZ, XYZ, you're going to divide the opposite by the hypotenuse. So what's my opposite?
Is 9
And what's the hypotenuse?
over 15.
And what is that equal to?
The same.
Okay. Now on your calculator, they want you to find sine A. What's angle A again? 37, right? So you're going to enter in your calculator sine 37. What do you get?
0.67018.
So it's 0.6. Okay. Close enough.
Just 1 second. You told me we have to keep
Yes.
decimals, right?
But then it's because these were turned out to be 1 decimal, I'm just going to leave it to the 1 decimal. All right. Now, they want us to do the adjacent over the hypotenuse. Okay? So, again, in the first triangle ABC, adjacent over hypotenuse. What's adjacent over hypotenuse?
4
4
over 5.
over 5. And what does that give me?
0.8.
Exactly 0.8?
Yeah.
Okay. Now in triangle XYZ, you're going to do the adjacent over the hypotenuse. So that's 12 over 15. What do you get?
The same, 0.8.
Now you're going to do cosine of 37 on your calculator. What do you get? 7, 9, that rounds to what?
98.
It was 0.798.
Yeah, 7986, so that's about 0.8. Very close to 0.8. Remember that the measurement of the angle is not exactly 37, right? It's
Yeah.
either rounded up or. All right. How about the opposite versus the adjacent? So the opposite in a triangle ABC, we're going to do opposite over adjacent, so that's 3 over 4. And triangle XYZ,
9 over 12.
okay? Now on the calculator, you're going to do tan 37. So, what have you noticed?
They are similar.
Yes. Now, if you look at your triangles, right, both triangles, these triangles, yes, their side length is not the same, right, but they have the same angles, right? They have an angle of 90, they have an angle of 37, both of them, right? So you see that these two triangles, they're the same. They're similar triangles, okay? They have the same angles, but they have different side length, okay? But no matter what I did, right, as long as I take the ratio of the opposite over the adjacent, or the opposite over the hypotenuse, or the adjacent over the hypotenuse, I turned out with the same answer for both triangles, right? So when I did opposite over hypotenuse for both triangles, I ended up with the same answer. When I did adjacent over the hypotenuse for both triangles, I ended up with the same answer. When I did opposite over adjacent, both triangles, I ended up with the same answer. But what's most important is, it's the same answer as sine A, so the opposite over the hypotenuse, turned out to be the same as when I did sine of angle A. And cosine angle A turn out to be the same as the adjacent over the hypotenuse. And tan angle A turn out to be the same as the opposite over the adjacent. Right? Even if I add another triangle with different length, right, as long as they have the same angle, I'm going to end up with the same thing. So even if I come here and I say, okay, 6, 10, 8, angle 37, 90 degrees. Guess what's going to happen?
Gonna be the same.
It's going to be exactly the same thing when I do opposite over adjacent, when I do adjacent over hypotenuse, when I do opposite over hypotenuse. They're going to be the same because they have the same angle. Okay? So this is what we call the primary trig ratios. If you look here, I can say that sine A is equal to opposite over hypotenuse. I proved it here, right? And I can say that cosine A is equal to what?
Cosine
Adjacent over hypotenuse. And I can say that tan A is equal to opposite over adjacent. This is where the so, ka, toa comes from. Let me show you what. If you look here, at your formula, sine starts with the letter S, right? Sine starts with the letter S. And then my formula is opposite over hypotenuse. Okay? So the formula is sine opposite over hypotenuse. So that's where the so comes from. So that's for you to remember the formulas. So, ka. Ka means cosine is adjacent over hypotenuse. Ka. C-A-H. To-wa. So that's tan is opposite over adjacent. Right? So the trig ratios can be used to calculate the side of a right angle triangle if I know an angle and a side are known. Okay? So the primary trig ratio SOHCAHTOA can be used in a right angle triangle to solve for a side if I know an angle and a side. I need to know an angle and a side to be able to solve the other side.